All right, 2.3, day 2. We're still talking about linear functions and slope. So our objectives for this part of the lesson, we're going to recognize and use a general form of a line's equation. We're going to use x and y intercepts to graph the general form of a line's equation. And we're going to model data with linear functions and make predictions. So every line has an equation that can be written in the general form of ax plus by plus c equals 0. It says where a, b, and c are real numbers and a and b are not both 0. So you have to have an x or a y, okay? You can't just have a constant equals 0. Some other things to know is that a and b cannot be fractions. Or let me do this. It's a, b, and c. So just to put no fractions. Or decimals, because remember every decimal can be written as a fraction. Okay. Also, a must be positive. All right, so in example 1, it wants us to find the slope and the y-intercept of the line whose equation is this. Well, remember, we talked about in day 1 that if we can get the equation to y equals mx plus b, that m is our slope and b is our y-intercept. So if I can solve this for y, then I can identify my slope and my y-intercept. All right, so let's do that. So let's move the 12 over. So we have 3x plus 6y equals positive 12. And then I'm going to solve for y, so I need to move the 3x over. And so we have 6y equals negative 3x, and I had a positive 12. And then divide everything by that 6. So we get y equals, reduce it, negative 3 divided by 6 is negative 1/2 x, and then 12 divided by 6 is a positive 2. All right, so there's my equation. We know that our slope is that m value, which is the number in front of the x, so negative 1/2. And we know that y-intercept is that b value, which is a number that doesn't have an x, so it's a 2. But also remember, you could write the y-intercept as an ordered pair as 0, 2. And so there are our solutions. All right, so using x and y intercepts to graph. First thing we're going to do is we're going to find the find the x-intercept. So you're going to let y equal 0 and solve for x. Then we'll plot that point on our x-axis. Then we're going to find the y-intercept. We do that by letting x equal 0 and solve for y. And then we'll plot that on our y-axis. And then we're just going to use a straight line to draw a line through the 2 points. Remember, it's a line that continues, so make sure you draw arrows on both ends. All right, so let's try this. So the first thing I'm going to do here is it says graph using intercepts. So let's find that x-intercept. So remember on the x-intercept, it said we're going to let y equal 0. So I'm going to rewrite my equation, but where I have a y, I'm going to plug in 0. Well, then we multiply right there. What's negative 2 times 0? 0, so we can say it cancels. So we just end up with 3x minus 6 equals 0. Now solve for x. So add the 6. So 3x equals 6. And then divide by the 3. And so we get x equals 2. Now if they want that as an ordered pair, remember your x is 2, says it, and your y is 0. We even wrote that above. So let's go to our x-axis and go to where x is 2, and let's put a point. All right, for the y-intercept, we're going to let x equal 0. So we're going to write down the same equation, but this time where we have an x, we're going to put in a 0. Well, what is 3 times 0? 0, so we say it cancels. So I just have negative 2y minus 6 equals 0. And now let's just solve for y. So add the 6. So negative 2y equals a positive 6, and then divide by the negative 2. So we get y equals a negative 3. Now if we wanted this as an ordered pair, remember your y is negative 3. It says so. And we'd even wrote it above. Our x is going to be 0. So we're going to go to our y-axis, go to negative 3, and put a point. Then we're just going to draw a straight line going through both of those points. And then make sure you put arrows on both ends because it continues. And then the application. Guys, on all of these, just look for the important stuff, okay? Look for the numbers. They're going to give you your ordered pairs so that you can write your equation, okay? It says use the data points 317 and 57.04 and 354 and 57.64 to obtain a linear function that models average global temperature f of x for an atmospheric carbon dioxide concentration of x parts per million. Round m to 3 decimal places and b to 1 decimal place, so we don't forget. All right, so I see they gave me 2 ordered pairs. So this is going to be my x1, y1, my x2, y2. And so it tells me to obtain a linear function, f of x. So remember, f of x is the same thing as y. So I want to write this equation as y equals, or I can put f of x equals there, okay? So the first thing we're going to do is we're going to find the slope. And so remember, you find slope because we know that that's our m, which is at y2 minus y1 over x2 minus x1. This is from the day 1 notes. All right, so I'm going to build my skeleton here, and I'm going to plug in. So my y2 was 57.64. My y1 is 57.04. My x2 is 354, and my x1 is 317. So we're going to subtract the numerator. So 57.64 minus 57.04 is 0.6 divided by, we're going to subtract the denominator. Sorry, I'm trying to get my calculator here. So 354 minus 317, I don't want to tell you wrong, it's 37. And so we got 0.6 divided by 37. So I'm just going to do that in my calculator. It gave me 0.016216 blah blah blah, right? But it says around m, which is our slope, to 3 decimal places. So right there is where we want to end. So what is a 2 going to make happen? It's going to make the 6 stay the same or go up? Well, remember 4 or less, let it rest. So this is just going to give us 0.016 for our slope. All right, so once we have our slope, we're going to use the point slope form. I'm abbreviated here, so use point slope form and solve for y. All right, so I know a point. In order to use point slope form, I need a point and a slope, which I know. I know my slope, we just said was 0.016, and I know an ordered pair. Now, it doesn't matter which one I use, because when I solve for y, I'll get the same answer. So I'm just going to use the first one, the 317 and the 57.04. I like that one because it doesn't have any negative numbers in it, and I also like it because the numbers are smaller. Not that they're a whole lot smaller than the other one, but still. But it really doesn't matter which one you pick. All right, so that's my x1, y1, and I know my slope. All right, so remember your point slope form is the y minus y1 equals m times x minus x1. And remember, we plug in for x1, y1, and we plug in for m. So I'm going to build my skeleton. Now, my numbers are a little longer, so give yourself some room here. All right, so I'm going to plug in my y1, that's the 57.04. Plug in your m, so 0.016, and plug in your x1, the 317. Now remember, this is point slope form. If it is said to write it in point slope form, we would be done. But it's said to solve it for f of x. So we need to go ahead and solve for y. I can't do anything on the left side, but I can distribute here on the right. So I'm going to bring it over here next to it. So I still have my y minus 57.04 equals, got 0.016 times x, and then I got 0.016 times 317, which is, or times, excuse me, a negative 317, so it's a negative 5.072. Then we're going to move the 57.04 over. So we get y equals got a 0.016x plus, I got 51.968, and it says to round b, which remember the 51.968 is our b, to 1 decimal place. So I need to round that 9. So this 6, what's it going to do to the 9? Is it going to make it stay the same or go up? It's going to go up, but a 9 goes up to a 10, so it's actually going to make that become a 52, isn't it? So we could put plus 52.0. You don't have to put the 0.0 though. Okay, so we still have our 0.016x in front of it equals, and instead of putting y, I'm going to go ahead and put f of x. And so this is our equation that it asked for.